parallel and perpendicular vectors. If A and B are perpendicular, a word you might see is orthogonal. Mathematicians use this word to convey the analog to being perpendicular when dealing with higher dimensional spaces, but you still sometimes see it when working in 2 and 3 dimensions. Then A dot B is equal to 0. So let's suppose we have two vectors. Let's call them A and B. We know that A dot B is the modulus of A times the modulus of B times the cosine of 90 degrees if the angle between them is 90 degrees. So even if the modulus of A and the modulus of B are non-zero, this whole thing will be 0 because cos 90 is 0. This is a very important concept, that perpendicular vectors have A dot B equal to 0. If A and B are parallel, then A dot B is either equal to the modulus of A times the modulus of B. That's because the angle between them is 0 and the cosine of 0 is 1. So this would be parallel vectors which are pointed in the same direction. Or A dot B is minus modulus of A times modulus of B. That would be the situation where they're parallel but pointed in different directions. Some people call that antiparallel. The angle between these vectors is 180 degrees, and the cosine of 180 degrees is negative 1. A very important implication is that for the unit vectors I, which we know is 1, 0, and j, which we know is 0, 1, I dot j is equal to 0. Remember, those are perpendicular vectors. And I dot I is equal to j dot j is equal to 1. Remember, I and j have a modulus or magnitude of 1, and the angle between them is 0. Determine if the following vectors are perpendicular, parallel, or neither. It's worth noting that all of the vectors here are some variant on 3 and 4, so 3, 4, negative 3, negative 4, and so on. So all of them would have a magnitude of the square root of 3 squared plus 4 squared, which is 5. So let's look at part A. If we do C dot D, then that's going to be 3, 4 dot negative 3, negative 4. So that gives us negative 9, take 16, which is negative 25, which is negative 5 times 5. So that's the modulus of t times the modulus of d, the negative of it. So these are going to be parallel. Now we can spot that from the original vectors. We've got one that's 3, 4, so 3 across and 4 up. And the other one is negative 3, negative 4, so that's 3 to the left and down. So these are parallel but in opposite directions. Now let's look at part B and do E dot F. So that's 3, 4 dotted with negative 3 and 4, giving us negative 9 add 16, which is 7. That's clearly going to be neither. It hasn't come out to be 0, and it hasn't come out to be either 25 or negative 25. Now to do g dot h. So that's 3, 4, dotted with negative 4, 3, giving us negative 12 add 12, which is 0. So these are perpendicular. We're now in a position to do exercise 4.04 on page 126.